Hello everyone, welcome to my Additional Max channel. For today's video lesson, I will discuss system of equation. So we have system of equation with no solution, right? So let's get started with the class.
Now here we have a system of equations and we want to solve for it. Now whenever we're solving a system of equations with three variables, remember we have to look at them in pairs. So let's say we look at them in pairs. So first and second equation in one pair and second and third equations in one pair. So we have this green pair and this pink pair over here. So start off with the green pair. Let's rewrite it. We have 2x minus 3y plus z equals 3. And we have 6x minus 12y plus 4z equals 8. All right, so now again, by observation, there is no way we can eliminate one of the variables. That's why we have to do some multiplication. So first equation, let's say we want to get rid of the z. That means we have to multiply the whole equation by 4, because 4 times z gives us 4z, and that is what we have in the second equation, right? So 4 times 2x is 8x. 4 times negative 3y gives us negative 12y. And 4 times z gives us 4z. 4 times 3 is 12. Okay, so now after making the changes, we can ignore this equation and just focusing on these two equations. Now over here, if we were to subtract the two equations, let's see what's going to happen. 6x minus 8x gives us negative 2x. Negative 12y minus negative 12y, we get negative 12y plus 12y, and they cancel out, right? And similarly over here, 4z minus 4z will cancel each other. Okay. Next, we have 8 minus 12 is negative 4. All right. Now, to solve for x, we have to divide both sides by negative 2. So here we have x, and negative 4 divided by negative 2, we get positive 2. Okay. So for this one, it doesn't seem so bad. We get x equals 2, and indeed it's actually pretty good. Right? Now let's move on to the second pair, this pink pair over here. So we write it on this side. We have 6x minus 12y plus 4z, and that will equal to 8. Now next, we have negative 3x plus 6y minus 2z, and that will equal to 6, like so, okay? So again, now we cannot eliminate any of the variables. So we have to perform some multiplication. So if we were to multiply the second equation by 2, right, this negative 2z times 2 will get negative 4z, which is equal to this term over here. Okay, so let's do it. 2 times negative 3x gives us negative 6x. Here, 2 times 6y gives us 12y, all right? And 2 times negative 2x gives us 4z, and that will equal to 2 times 6 is 12. All right, now we have made the changes, so we can ignore this middle equation over here. Now just look at these two equations, all right? Is there anything you can eliminate? Well, let's say we add them up, okay? Let's see what's going to happen. 6x plus negative 6x, so we have 6x minus 6x. They cancel out. Negative 2y plus, negative 12y plus 12y, they cancel out. And 4z minus 4z, they cancel out. So you see the left-hand side, everything got canceled out. So the left-hand side, we just have 0, okay? For the right-hand side, we have 8 plus 12, and that will equal to 20. So here's the question. Is 0 equal to 20? No. No matter what you do, 0 will never equal to 20. So if this statement can never be fulfilled, that means there is no solution, right? Because 0 can never equal to 20. right? So even though x is equal to 2, we found that over here, right? However, over here, we see that there is no solution, right? So, in conclusion, if whenever you're solving the system of equations, whenever you come up with a strange statement like this, 0 equals to 20, right? That will give you no solution for this question. Actually, this second and third equations are indeed multiples of the first equation. And why is that? Let's take a look. Here, first equation states that we have x plus 6y minus 7z equals negative 2, right? If we multiply the whole equation by 2, right, what do we get? 2 times x, 2x. 2 times 6y, 12y. 2 times 7z, 14z. 2 times negative 2, negative 4. And you see, this, it's exactly the same as the second equation over here. So this is the second equation, right? All right, so now, if we were to multiply the first equation by 4, let's see what is going to happen. 4 times x, 4x. 4 times 6y, 24y. 4 times 7z, 28z. And 4 times negative 2, negative 8. Okay, again, you see, 4x plus 24y minus 28z equals negative 8. So this is indeed the third equation, right? Just as we said, the second and the third equation are multiples of the first equation. So indeed, they are all of the same equation. So remember, for each equation, it corresponds to a plane on our 3D graph. So if they are all of the same equation, that means they are all talking about the same plane. Or another way of saying that is, 3 planes are exactly overlapping on the same plane. And in that case, what is our answer? If everything is overlapping, that means we have infinite amounts of solutions, right? So all in all, the answer to this system of equation is infinite solutions, because we're talking about the same equations. All 3 equations are of the same. That means everything is overlapping. If they're all overlapping, we have infinite solution. Okay? Over here, we want to solve for this system of equations. All right? So here, again, let's consider the first 2. Okay, let's take a look at the first 2 first. We have x minus 2y plus z equals 3. And we have 3x minus 6y plus 3z equals 9. Right, it looks a bit ugly, so let's rewrite it. Minus 6y and 3x. Okay. So here, again, the second equation, it's indeed the first equation multiplied by 3. Okay. So if we multiply the first equation by 3, we'll have 3 times x, 3x, 3 times negative 2y, negative 6y, 3 times z, 3z, and 3 times 3, 9, right? So these are of the same equation. So here, same equation, no infinite solution, right? So here, we can already conclude that it has infinite solution. Now, however, some student might ask, all right, what about this equation over here? This equation, it's not the same as the previous 2 equations. So, do we still have infinite solution or not? Okay, so here's the problem. Just as we said, if we have 2 equations of the same, that means we have 2 planes overlapping, right? Now, these 2 overlapping planes, we can consider that as 1. Now we have another line, another plane that is different from this plane, so they will cross at a point. So you can imagine 2 planes crossing. What is the intersection point? Well, that intersection point is not actually a point, it's a line, right? So 2 planes intersecting, that will be a line. So for a line with, we still have infinite amount of answers. but it's on the straight line. It's not any point that you can have, but it's any point on that straight line. So if we want to find that straight line, we can keep on solving for this system of equations and find that line out. Okay, so here, after considering this pair, we can consider these two pairs. We have, let's write it over here. So we have 3x minus 6y plus 3z equals 9. And we have 2x plus 5y minus z equals negative 6, right? So solving this, we will have to multiply our second equation by 3, so that z will turn into a 3z, right? So this 3 times 2x, 6x. 3 times 5y is 15y. And 3 times z is 3z, right? 3 times 6 is 18. Okay, so now we ignore this equation because we've made the changes already. Now, we add them up. Let's see what we're going to add. 3 plus 6, 9x. Negative 6 plus 15. We'll have positive 9y. 3z minus 3z, they cancel each other. All right? And 9 plus negative 18, we get negative 9. All right, so all in all, you see, now we have a straight line, right? And we know that it has infinite solutions. So on a straight line, it can be any point on the straight line. So that's why we have infinite solution. And if we want to know what are the possible solutions, it is any possible points that fulfill this statement over here, right? So all in all, but if you don't want to know that, we can stop over here and conclude that for this system of equations, we still have infinite solution.
Alright, thank you, sir. Right, that's all for today's sharing. I shall see you all in my next video sharing. Bye bye and have a nice day.